Geology? Geology? Geology! This is Daniel Minizini, your inquisitive geologist from KPFT HD2 channel. We are in Houston. This is Mini Geology radio show. We talk about geology and we put it in relationship with society at large. And I'm so glad to have here with us today Cathryn Manduca. Do I pronounce it well, Cathryn?
Yes, you did.
Cathryn actually is not physically here in the studios of KPFT. She's in Minnesota, is that right?
That's right.
All right. So Cathryn, she is, I think, a very important person. I've been inspired by her writings. I would call her kind of the doctor of the geologist, the physician of the geologist. She looks inside ourselves. And when I say ourselves, I talk about geologists. She kind of makes us conscious about what we are as a body of professionals. So she's going to tell us today who we are and why we are like that, or how we are evolving as a profession, and who drives or steers our evolution. I'm really sure that she knows this because she has published on how we geologists we learn, how we think, and how we teach to our younger generation, and how we run our geological department. So Cathryn Manduca, she is in Minnesota right now. She's the director of the Science Education Resource Center at Carleton College. She is also executive director of the National Association of Geoscience Teachers, and she also is the principal investigator, the lead principal investigator for the Integrate, which is an NSF STEP center in the geosciences. So this is about science, technology, engineering, and mathematics. Plus, she also serves on the AGU board of directors. At least this is what is written in the website when I read about your CV. Is all of that correct, Cathryn?
Well, my term on the AGU board ended in January, so
but
the rest of it's all correct.
Good. And what about the board on the science education of the National Academies of Science?
I still serve on that.
All right, so here we go. We integrated your fourth hat. Welcome to the show, Cathryn. Welcome so much. Well, Cathryn, tell us, what is the status of the art on the education of geology in the USA?
The state of the art on geology education. Well, I would say that geology education in both the K-12 system and in higher education is undergoing a transformation where we spend as much time helping students understand how we know things and learning how to think like geologists as we do giving them the contents of our understanding. So that, I think, is a major focus, and I think the other sort of state-of-the-art piece is that we're becoming better at how to go about helping people learn, and in particular moving away from talking at people and instead engaging them in doing science and doing aspects of science in their education.
What is the main difference in between talking to or engaging into?
Oh, well, think about what it's like when you're doing science in the lab. How much of the time or out in the field, how much of the time do you spend talking versus doing? So the emphasis in geology education is moving away from standing in front of students and telling them what we know or that you know, and toward in helping them have the experience of doing geology themselves.
So that is true. Then that would mean more lab time, more field trips. Do you see this happening also in the universities?
So I would say that there's no extra time in anybody's day or in anybody's class schedule. So I think the biggest shift that's undergoing, that's happening, is what people do with the time that we used to call lecture time. So there are increasing uses of other ways of spending that lecture time. So, for example, if you think about a class where everybody read the book before they came to class, all of the things that you could do in class instead of telling them what was in the book. So that kind of thinking is taking hold, and lots of strategies for getting there, from recording things and posting them online so that students can view that content information that you would give if you were lecturing, to just completely rethinking how you expect students to get content, and moving from, read this, come hear about it, and then tell me about it in a test, to thinking about how one can learn that content in the context of trying to undertake an investigation.
And how do you know that this technique works?
Oh, there is lots of research now on, and there has been actually for quite some time, on how people learn, including students. And so we know a number of things in a number of different ways. We know from psychology the sort of principles of learning, and they've been studied for a long time. And sort of one of the most foundational principles is that people have to construct what they learn by integrating it into the things that they already have in their head. And we know that from psychology that doing things, that one can do that from listening. Certainly lots of people, including many people who learn very effectively from lecture, can do that by listening. But you can also do it in other ways, and reflecting and doing and communicating are all really valuable strategies in doing that. We know from studies of classrooms we know from studies in classrooms, especially beyond the geosciences, that when you teach students, if you compare how they perform on tests when they have been lectured at to how they perform on tests when they have engaged in doing some sort of activities, that they do better when they're doing activities. And we know that in particular, students who are not who are from underrepresented groups that are underrepresented in the sciences have more gains engaged teaching practices helps them do better even more than everybody else. So so that suggests that that you can reach a much broader audience if you're not lecturing than if you and you're designing your class based on these principles of engaged teaching and learning.
So this is true for K-12, college, universities, or is a specific age for the students in order to learn through this technique?
So in the study that I just talked about for students from underrepresented groups is from college-age students. The principles of learning are from our principles of learning. So you would, once students have an adult-like mind, those principles would apply. I'm not as familiar with the research on learning in the K-12 environment. My understanding is that it would show the same kind of result.
Now, what is special about geologists? Is this technique available for everybody and maybe useful for all other disciplines? What about geologists?
Well, geologists think and learn like other people. We haven't undertaken the same. I'm trying to think if this is true. The definitive studies, the most definitive, biggest studies have not been done in geology, but there's no reason to believe we wouldn't see the same kind of result. And there are lots of smaller studies that show engaged strategies being effective in geoscience. I think the most interesting thing about geology is trying to think about what those strategies mean for us. So you talked a little bit about, does that mean you're out in the field more? What does it mean? What does it mean to have an opportunity to engage in geology, and how do you do that in a classroom? So, there's quite a bit of work on, quite a bit of work on engaging students in undergraduate research in courses as well as outside of courses. There's work on there's work on how students learn visually and in the field, and how you can make field trips accessible to students without having to go outside. So how do you scale up the use of, how do you remove the barrier of having to go on a field trip if you can't take all your students on as many field trips as you would like to do, using virtual reality kinds of strategies. Those are some examples. There's a lot of work on how geologists do a tremendous amount of work with large data sets and also with visual data. So how do you design learning activities for students that help them make sense of big data sets? So I think one of the really interesting places is to think about, it's not the case that you can expect to be successful if you just take students and dump them in the middle of a big pile of data, or dump them out in the middle of the field. I mean, we all know that from teaching and from our own experiences. So what are the ways in which you can help students make sense of it? How do you guide them from a place where they don't know what to do when they're dumped in the middle of the field or in the middle of a big data set, to a place where they know what to do, and what are the steps along that way? We call that scaffolding, and it's thinking about, okay, the first time you see a big data set, what's going to be really helpful to you in terms of how to make sense of it, and then what of those things how do you learn to have those thoughts and ask yourself those questions without somebody else posing them for you?
You mentioned virtual reality. What do you think about virtual reality as a method to teach students?
Well, I think that there is a lot of opportunity there. I don't think that it necessarily replaces taking people out for direct observations in the field, but it has a lot of opportunity for providing access to people who can't get out in the field or can't get out in a particular kind of field. And it also has a lot of opportunity for thinking about new ways of helping students visualize or scaffolding their initial experiences.
Isn't it a slippery slope, the virtual reality? Because at the very beginning we would say, of course, let's see Antarctica in virtual reality, or a place that geopolitically is pretty unstable. And then little by little you lose the ability to go to the field, or you become lazy and you don't go out to the field anymore.
Well, I think that would be an unfortunate outcome, but you can say that about lots of things. I mean, should we not use calculators because they decrease, or not use computers because then we don't have to know how the underpinning equations work? I think if we have a strong rationale for what's different about going out in the field versus virtual reality, and a strong rationale of how and when we use which kind of opportunity, then we should have, it may be a steep slope, but we should have some good ice axes in it, or pitons, or whatever you want to have hold you up.
Yes, I see that analogy with a pocket calculator. But still, a mathematician is a good mathematician even if he uses the pocket calculator. But a geologist is not a good geologist if he can't stand out in the field. Instead, he uses the virtual reality.
I guess I'm not understanding I'm not understanding why you think the analogy breaks down. So a good geologist, just as a good mathematician could be a good mathematician and use a calculator, a good geologist could be a good field geologist and still use virtual reality, I guess is the way I would put it. Oh. And certainly the way in which one develops a good geologist as a student or a good mathematician as a student could combine aspects of using a calculator and understanding and learning fundamental principles of mathematics, just like you could combine taking students out in the field and augmenting that learning through virtual reality.
And Cathryn, why do you try to improve? Why do you improve education and enhance it, and you bring it to another level? Is this to create more geologists, or to create better geologists, or just to create awareness about the subjects that are mastered by geologists in the university, where students they can take a minor instead of a major?
So for me personally, I'm motivated by a couple of things. One is that I think that the more people who understand geology and understand the planet they live on, the more successful we as a species will be on living on that planet now and in the future, and the more able we will be to make good decisions about how we impact that planet and how we are impacted by that planet. So I am really interested in very widespread geoscience literacy throughout the population, and I think K-12 and higher education provide a lot of opportunities for that. I'm also really interested in having a good geoscience, good workforce that has access to the geoscience information it needs, and that is, that has to do with how geoscience majors are prepared and how majors in other fields get access to geoscience. And then I'm also really interested in making sure that workforce opportunities to both be geoscientifically literate and to enter the workforce are available to everyone in our society. So geoscience is one of the least diverse professions in the STEM fields, and is particularly notable for the paucity of people from of African Americans, Native Americans, and Hispanics, and that to me suggests that we are not currently providing the same kinds of access and affordances to all different kinds of people.
So you do a lot of work of, let's call it outreach, if you want to engage people that they are not necessarily geologists, right?
The Integrate project that you just talked about when you introduced me was a project that was designed to, so its goal is to teach geoscience in the context of societal issues, which means bringing societal issues into geoscience and taking geoscience out into the rest of the undergraduate curriculum. So that's one of the important strategies that I think I've been most active in pursuing myself is thinking about ways to get access to geoscience make geoscience of interest to a wider group of people, and then also geoscience courses of interest to a wider group of people, and then also think about how to get geoscience information into other kinds of courses.
Cathryn, you have great ideas and you manage very important projects. Who teaches you how to teach or how to educate better?
Oh, well, I would say the faculty around the country and the geoscience education researchers and the education researchers are doing that for me. So I actually don't personally teach students. I'm not a faculty member. I run the Science Education Resource Center. I teach faculty on some occasions, though mostly I make communities where faculty can teach each other and learn from each other and learn from experts in educational research and geoscience educational research. But the places I go to learn about what's working in classrooms are to the experiences of faculty integrated with the results of research on learning, both in the geosciences and beyond.
So it means that you sit down with them and you talk with them around the table, or you read their papers, or you're part proactively of their research?
Oh, that's a great question. So geoscience and geology are are really, really fortunate to have a big, strong community that talks about teaching and shares its teaching practices. And there are a couple of vehicles for being part of that community. Certainly NAGT, the National Association of Geoscience Teachers, is one. NAGT runs a meeting in the summer called the Earth Educators Rendezvous, which is attended by 250 to 350 educators, K-12 and higher education, each summer. And that's a place where education researchers and faculty come together to share what they're doing in the classrooms and what's working and what are the latest research results. And that's a really fun meeting. It combines opportunities to be in multi-day workshops with opportunities to give papers and hear papers and be in short workshops and hear plenary speakers. So, that's a really fun opportunity. I have then the other sort of big place that one can go to learn about geoscience teaching is the Teach the Earth website, which is part of was developed by me and my colleagues, particularly on the cutting edge PIs who started work on this about probably almost 20 years ago now. But what we did was to develop mechanisms for faculty to come together in workshops like the Rendezvous and then share their teaching practices and their research results via an online resource, Teach the Earth, and they could contribute teaching examples. And so we continue to develop new aspects of that, ran a bunch of small workshops to learn about what people were doing. The traveling workshop program that's being run by NIGT takes faculty takes leaders to people's departments and helps bring some of that information to them. So, lots of opportunities. The way I learn is to be in the midst of this community. And, I also read papers and I do some of my own research and, review proposals and all the other ways everybody learns about research from other people. But I really feel like we're very fortunate that we have this huge website and we have this great community and, it not only does one big thing together in the summer, the Rendezvous, but it has lots of other things going on that people can participate in. Information moves pretty easily around that community. Journal of Geoscience Education in the trenches are great places to go to learn what's going on.
So, Cathryn, we learn what are your, let's call it, sources of information, where you go to discuss, debate, and bring the problem at a higher level. What about the sources of your inspiration, those that allows you to connect the dots, the ones that they allow you to come up with a new idea?
Well, I'm inspired by the people around me. I mean, the other source of information and inspiration that I have is working with faculty and leaders, people who do the same kind of work I do in other disciplines. And the Board on Science Education is a wonderful opportunity for that. You mentioned that I'm on that. A lot of inspiration for me just comes from riffing off ideas with other people. So, talking to people and people who want to collaborate. I do a lot of collaborative work, and I love collaborating with people. So, we'll get together on the phone or on Zoom and say, somebody will say, "How about if we do this?" And then I'll say, "Oh yeah, we could do this. It's going to be sort of like that." And they'll say, "Well, yeah, but we could do this." And, I get a lot of inspiration that way.
Cathryn, also, I would like to ask you. Now that we know your background and the things that you do, how would you define a geologist from your professional point of view? Help us to understand who we are as a professional.
Well, thank you. So you introduced me as a scholar of that, and I'm not really a science philosopher, but I have had the opportunity to both be trained as a geologist and to spend a lot of time around geologists. And so, as you know, I worked on a project with Tim Castens to try and understand how geologists think and learn, and at the heart of that to try, and for me, the project did lots of things, but for me, one of the things I wanted to do was to see if we could find a description of geologists that, and actually of geoscientists, that was broad enough that it would unite the different kinds of geoscientists, from geologists to atmospheric scientists to ocean scientists and from experimental petrologists to field geologists to, geophysicists. Unite that breadth, be broad enough to have that breadth, but be specific enough to define that group and not apply to every scientist. And so Kim and I spent a fair amount of time talking with people and thinking about that, and really came down on a couple of places. One is that geoscientists are defined in part by what they study. They study the Earth and the planets, but that's not a very satisfactory answer because, physicists can study anybody can apply what they know to that, to some object. So we looked a lot at the methods of geoscience, and in particular what constitutes proof in the field and the nature of evidence and reasoning. And so there were some interesting things, I think, that came out of that. One is our use. One of the ways that one of the things that I think is really true about geologists and geoscientists is that the way they come to understand if something is true or not, or whether or not there's evidence for it, is to make, you alluded to this, is to make direct observations of the Earth. So, that grounding, and then they test their theories. They test their theories about, it's not enough just to make direct observations. There's got to be some distance between a hypothesis about how the world works and an observation. So they go back and forth between this idea of theory or hypothesis and observations, and they use lots of different ways to make predictions about what they expect to find on the Earth based on different hypotheses. So it's kind of that ground truthing was one of the things that we really focused on. Another, I think, really interesting thing is the way what we consider evidence, or how we come to evidence. And one aspect of that is the way we use lots and lots of different methods and different ways of understanding a problem, and then we look for convergence in the results. So bringing together multiple different kinds of reasoning. That sounds, to a geologist, that sounds like obvious, but that's not actually the way other disciplines work necessarily all the time. And we're particularly, I think, happy to have lots of different ways of going at a problem coming together, because we so rarely have all of the information we need from any particular line of reasoning. And then another thing we do a lot of is to compare cases from different places and look for commonalities among cases, and then deduce theories from that. So, there were some interesting ways about thinking about the nature of proof in our field. And then the other sort of place that we didn't make any headway at finding, common knowledge and skills. So there certainly are common knowledge and skills, but our field is so broad that they kind of overlap in, interesting and non-diagnostic. There's relatively few things you can expect every geoscientist to know. But there are ways that they look at the world, and that was, I think, the other sort of interesting sort of feature of this work. We're grounded in observation of the natural system. We typically think in geographically, spatially, and temporally organized ways. We reflect on the long history of geologic time, and the importance of geologic time and temporal thinking is really important to geoscientists. And then dynamic complex systems are, of course, a sort of fourth perspective that I think we bring to our, I think you could claim that geoscientists always bring those four perspectives to their work. And then lastly, we talked about the nature of collaboration in the geoscientists and geosciences, and how, because of the nature of proof, collaboration is really it's to our advantage, given the way that we prove things, to be able to collaborate well, and that's a wonderful thing about geology.
Yeah, so you probably have in mind also the what you call the community of practice that has always shaped the geologists through a robust and distinctive cluster of experiences and approaches and perspectives and values also. Mm-hmm. Mm-hmm. So because I think that none of these attributes, they taken individually, are unique to the geologist.
No, that's right. That's right. Lots of people have one of those attributes or several of them.
Yeah, but we as a group, as the community of practice, we have them all.
That's right. That's right. And I think one of the points that Kim and I made in our paper was that the reason that we are the way we are, geologists and geoscientists, is that the nature of the knowledge that we're seeking, our drive to understand how the Earth works, has led to the evolution of our practices and our culture to support our ability to do that well. And just as physicists or chemists or biologists, their work has evolved in different ways to support them in being able to do what they do well.
So now that we know who we are, Cathryn, would you mind to tell us what is, from your point of view, the role of geologists today?
Well, I think that geologists and geoscientists more broadly have some important understanding of the planet that is important in lots of different ways. So I think one of our roles is to, participate in I would say that, let me say it this way. I think that we have a very fundamental and important ethical role in bringing that knowledge to the society in which we live and helping that society live sustainably and justly and soundly, I guess I would say, on the planet. And for me, that there are values I think every geologist has that obligation to bring their work to bear on the society around us. Some of us have different values than others. Everybody's entitled to their own values, but I think that the obligation is to engage, is to not withhold that knowledge and turn away from the society we live in. So I think that's a sort of an important foundational role. How people bring that and where they bring it is different for different people. So clearly there are really important roles for geologists to play in environmental concerns, in resource concerns, in climate concerns, in understanding the history of the Earth and applying that, helping people to have a philosophical perspective that involves a large timeline. I mean, you can just think there are so many different ways in which geology is fundamental to society right now, and also fundamental to our ability to advance the scientific understanding of the Earth and ability to advance science more broadly. I mean, we bring a perspective and techniques that are attuned for understanding the Earth, but also valuable and important in understanding other things. So, I don't know. I have a big tent perspective.
Well, when this is today, 2019, this is the role of the geologist. What about projected in the near or long-term future? What do you think that the geologist may contribute to the society? Because right now, as you said, we need to engage, and especially in those topics that are in a public arena, like resources and environmental issues right now. But what about in the future?
Like, what do you mean by future? Like 10 years? Like 50 years?
Both.
Well, my guess is it's hard to, I mean, on a 10-year time scale, I think we will need to continue to engage. I mean, the importance of geoscience understanding in the current societal discussions is clear. You know, we have lots of people on the earth, so we have lots of hazards issues. We have climate change happening all around us. That transition is faster and faster, and we're to the point where, you know, knowing lots of geology is helping in all sorts of ways, not just knowing that the climate is changing, but knowing how to respond to, you know, we just had a blizzard, how to predict the weather, how to respond to a flood, how to understand how a flood is likely to behave in the future, how to, you know, all of the hazards that are really, how geologic health, you know, how the interplay of environment and climate and health is, you know, what do we know about what that's all likely to be like, how to respond, how to make people more resilient. We don't know all of that, but we need to be involved in helping to, we need to bring what we do know to the table as society is trying to grapple with those kinds of changes. On a 10-year time scale, we'll be 10 years further down the road, and we'll know some more things, and we'll have tried some experiments, and some of them, some social experiments, and some of them will have worked, and some of them won't have worked, and there'll still be a big role for us to play. The questions will change, the research will change, but the need to engage won't change. And, you know, I guess I feel like that's always been the case. I mean, if you think back 100 years, 150 years, 200 years ago, geologists were just as important to society. The issues were more around resource issues than they were about environmental management, but, you know, it was still really important to society to have geoscientists contributing what they know about the Earth to
very important.
Improving.
And during those times, the university didn't have a proper and formal way to teach and to form geologists. So, in a way, it was pure curiosity, sometimes from those citizens that they had money enough to have the luxury to go around and pick up rocks. But now that we have a formal education, yes, we probably can also try to decide and steer where the education is going, which is what you are doing.
Yeah, so interestingly, a couple of years ago, I went to the 200th anniversary of my geology department. So that was fun. So geology programs have changed over time. Education has changed over time. It's quite clear that right now it's very important to work for widespread community literacy. The communities need geoscience literacy in order to be able to respond to the environmental issues around them. So, you know, that's an important strategy, important thing to focus for geoscience education right now, formal, informal, the whole enterprise of geoscience. That's an important focus right now. It's always been the case that what people learn is shaped by is shaped by people. And for the last, I'm just thinking about what the opportunities students have to learn about geoscience in the high school and in the K-12 system in the United States. And those opportunities are not as robust as geoscientists would like to see them. But the opportunities are there because geoscientists lobbied and participated and were effective in making a case for the importance of learning geoscience. And that role and response, that's another really important role for geoscientists in society, is to help make those opportunities available, not just by teaching, but also by working on a policy level. So, from working within the states around what the state science standards look like, to working in the school district as a member of the school board, or an advisor to the school board, or advisor to the Gifted and Talented program. There's all sorts of opportunities for opening up, working with the local nature center, working with the Girl Scouts. There's all sorts of opportunities for everything from volunteering time and expertise to working on policy issues in a whole wide variety of venues.
What about the professionality of the geologist? I see in my experience that on one side we are requested to be more generalists in order to address all the broad breadth of expertise that are required by the new scientific questions and also the societal problems. So you need to be able to see the essence of every subdiscipline and bring them together. On the other side, I see also the need to become more specialist in order to better understand those things of our disciplines that are not understood yet, and so further apply the disciplines that we master, because technology is advancing so much and you have to follow that technology in order to use it for your benefit, the benefit of your subdiscipline. So I'm wondering, you that see a lot of geologists geologists in all their colors, if we go more towards generalist or specialist, or maybe we need them both now.
Yeah, I think we need them both. And you talked earlier about the geoscience community of practice, and so in my mind, science moves forward at a community scale. Individuals contribute, but it's the community that makes it. It's the aggregate effort that tests and verifies ideas and brings them into use, and that community needs all different kinds of people in it. People that go from being highly specialized. Just think about the science. Just think about an individual research project. So I'm a geochemist and field geologist by training, and in the problems that I worked on in that arena, progress wasn't made by me. It was made by me collaborating with somebody who was a geochronologist and somebody else who had deep expertise in geochronology, but not as much expertise in the geology of the area I was working in, and then people who had that whole span that went from having, moderately deep expertise in both a technique and in a place, to people who really had deep expertise in the place, and not in any particular technique. So it is the interaction effect among those from which the real understanding emerges. And then if you think about the importance of having that information finding its way into use in society, you need another set of different kinds of people. You need people who have deep expertise in society, and you need people who have deep expertise in geoscience, and you need people who can span that range and have moderate expertise in both of them. And so you just need all different kinds of people, and then the ability for them to work together effectively and support for all of those different kinds of expertise.
I see. So it's kind of is like the community, that community of practice that we already have is kind of growing and agglutinating different other groups that they are not essentially scientists, let's say, maybe more related to understanding the society. And therefore, maybe we are changing a little bit because we have the agglutination of the different groups. Could that be something right?
Well, I would say that the most striking thing in geoscience to me is the development, and you can see this in geoscience from an education perspective and from a societal interface perspective. So the importance of people who are clearly geoscientists, who clearly have geoscience expertise, but but also bring expertise in another arena is becoming incredibly important. So I'm a good example, right? I have expertise I have a PhD in geology, but I also now have tremendous expertise in geoscience education, right? And so I'm both a geoscience I'm both an educator and a geoscientist, and we now have a growing group of people who are both a geoscientist and a person who brings geoscience into society. Those people then work with, very effectively, people who are straight educators who you wouldn't call geoscientists at all, or straight policy people who you wouldn't call geoscientists at all. But that's a gradational boundary, right? So, and where you draw the line between who's a geoscientist and who's not is, in my mind, not an important thing to draw. but that's it's a gradation. It's like a solid solution from one end to the other.
Yes.
And valuing that is really, really, really important, because if we don't value that whole spectrum, then we impede the ability of our community to do its work and to interact with other communities in productive ways. So
how do you value? How do we value that? Who is the factor that tells us we are giving value to these new figures?
Well, one way to tell if you're there are a couple of, people value things internally, and the aggregate individually, and the aggregate values of our community reflect the individual values. But there are ways of looking at what the community is signaling its values as a whole. So I'm thinking about two big institutions. One would be our professional societies and what they value. You can see the importance of increasing valuing for the interface between science and society at, for example, the American Geophysical Union, and the sections and awards and initiatives that it undertakes. You can see on the flip side, you can see the valuing that's placed by our institutions of higher education by looking at where what kinds of activities it rewards in the tenure and promotion system. That's where I look to see what are the, and you can actually, in higher education right now, you can feel the push on higher education to change those values from lots of different places as you hear people talking about what kinds of modifications are needed in the tenure system.
And you mentioned the professional societies. What do you think is the role of the professional societies right now, when we have the younger generation that is not really engaged so much with the professional societies? When I go and I see them, the few that I'm familiar with, they are mainly senior people.
Well, I guess I don't think that's true. When I look at either the Geological Society of America or the American Geophysical Union or the National Association of Geoscience Teachers, I see lots of young people. I see lots of students. I see lots of students asking for more opportunities. I see lots of people of all different ages and all different interests.
Also, as volunteers in the board, or only as members?
So that's what I was going to say. I think what is a professional society is an interesting question. So I see certainly AGU has huge numbers of students incorporated into all of its activities. From the board has a student member, there are early career, or has an early career member. There are early career members on the council. There are, actually, I think take that back. There are early career members on the council, not on the board. I don't think there's a dedicated seat for early career on the board, but on the council there certainly are. In their all of their activities, so there's the leadership. There's also who's engaging in what kinds of activities, and what's being supported. So certainly young people are publishing in journals of all kinds of professional societies. Certainly young people are attending meetings. Whether or not young people are signing up to be members is is also how young. I think that one of the big changes is how young people how they think about membership, and when they think it's important to buy a membership, and what they think membership is about is somewhat different than it was. It's different in people my age than it was in my parents' generation, and that's sort of changing. But that's the kind of thing that changes, and the structures adapt, but I don't see any evidence that young people are withdrawing from the scientific community or from the geoscience education community.
Cathryn, why most of the, or almost all of the famous geologists, they are senior, and there are not famous young geologists like it happened for many other scientific disciplines?
So give me an example of why you say that.
Because I see that we have to create special awards for young professionals, while if you are talking about chemistry, mathematics, physics, the 30-year-old professionals, they compete with the 80-year-old professionals. While in geology, there's no competition. The young geologists, they cannot compete with the old geologists.
Well, I'm not sure that I completely accept the premise, but if the premise is true, I would posit that the difference between, say, physics and geology is that, and this is not original thought to me, is that geology is a synthetic discipline, right? So the more geology that you know, the more able you are to make syntheses that are breakthrough, right? So breakthroughs are coming from a grounding in a broad knowledge. So, they say the best geologist is the one that's seen the most rocks. So it takes time to accumulate that kind of knowledge and be in a position to make a breakthrough of that sort. Whereas in physics, and again, this is not me that made up this answer, but in physics, you're looking for, or in math, you're looking for a insight that can come from a spark of inspiration that doesn't require having that huge corpus of knowledge behind you. You certainly have to have knowledge behind you, but it's not necessarily the same kind of collection of lots of details that supports that kind of insight. But I'm not entirely convinced that's true. I think there are young geologists that are having really important insights and compete quite well with older geologists. I wonder if part of the difference is the way our prize structures our awards are structured, and the culture that's associated with how we give them, and not so much with the quality of the insight that is being had by young and old people.
Cathryn, something about semantics. You generally talk about geoscientists, and I always mention geologists. What is the difference between being a geologist or being a geoscientist?
So, to me, geology originally was a term that meant people who study the earth, and to me, that's what geoscientist is. The earth and geoscientists, in my mind, study the earth and planets. But geology over time has often been taken to mean people who study the solid earth. And geoscientist, to me, is a term that embraces, as geology has been in the past. So maybe the difference is that you have a stronger grounding in European language, and I have a stronger grounding in U.S. language. That may be all the difference we're feeling. But but to me, or maybe you have a stronger grounding in Latin, maybe, for all I know. Maybe just a stronger grounding in Latin.
Definitely had to study for 5 years Latin. So.
Yeah. I only had 1 year of Latin ahead of me. But anyway, I use geoscientist because that's the word that AGI, the American Geoscience Institute, has asked geoscientists of all kinds to use, in part in response to people who didn't want to call themselves geologists because they didn't think that was a broad enough term. So to me, geoscientist encompasses atmospheric scientists, ocean scientists, solid earth geologists.
Yes, you're right. So right that I don't know. Well, my own department in Bologna, in Italy, changed name while I was studying from geological sciences, or from geology to geological sciences, including many others, and but they were teaching the same things. And also I see that some departments now, they changed their name from geological department to geoscience department, or even earth, planetary, atmospheric, environmental sciences. I don't exactly know why, so I was just thinking about it.
Well, I think lots of times those kinds of name changes are related to trying to make sure that the language is understood by all different kinds of audiences, and the people who are bringing one history of language. Atmospheric scientists certainly don't think of themselves as geologists in the United States, at least not most of them. And so trying to make sure that everybody feels represented in the language and that the rest of the institution understands what they're talking about oftentimes drives those name changes. And recently there have been lots of name changes that are related to mergers in departments, so that's another thing that's going on, is this reorganization of academic units.
Yes, that would be another important topic, the integration of departments. Sometimes to survive, sometimes because they really do breakthroughs with those integrations. Well, Cathryn, we are almost at the top of the hour, and I thank you so much. There's an open mic in here. If you want to add something, shout out, or say whatever you need, the mic is yours.
Well, I would just say thank you for having me. It's been a pleasure.
Well, Cathryn Manduca from Minnesota, Director of the Science Education Resource Center at Carleton College, and Executive Director of the National Association of Geoscience Teachers. Thank you very much for being with us at Mini Geology Radio Show at KPFT HD2 channel. Thank you again, Cathryn.
Thank you.
Like a drum